So I have this idea that I want to create a program that is kind of a similar Spirograph program. It's going to draw some circles. I would already have a description of the program that I want to write, so I'm going to enter that description. I've described it this way. This is kind of the problem statement. This is a program that draws a bunch of circles in a circular pattern, varying the color so that you can see every circle. In the end, you'll have a circle of circles. I will let the user enter a number that will be used to determine how closely together the circles will be drawn. All right, so the question is, how do we write pseudocode for this program? So the first thing I think I'm going to need is Turtle's library. Next, I'm going to ask the user for input on how to get information on the amount of space there's going to be between each circle. So in order to do that, I can't remember how to write pseudocode, let's say, in a way that is acceptable to AP. So I'm going to go to the AP reference sheet and look for how to do that. So I know I want user input. Just by scrolling down right on the first page, I see that using the all capitals, input, open paren, close paren is a way to do that. I also know that if I'm going to want to ask the user to input a value, I'm going to need to tell them using a display command to enter what they're entering the value for. Let's do that. Okay, so it's going to display the message, please enter a gap size for the spirograph. Then we got from the reference that we're going to use the input. We're going to input. So once we get something from the input, we're going to have to put it into a value. So we're going to assign whatever the user inputs into a variable. Let's call it, since we're calling this the gap size, let's call it size of gap. I'm going to write the rest of the pseudocode. Okay, I've completed writing the pseudocode for this program, I think. Let me talk about what it does. So I'm just going to quickly go through it. So in the beginning here, remember I got input from the user on what the size of the gap was going to be. We're going to have to remember when we write the code that that is going to need to be an integer. In any case, so I'm going to create a new turtle and I'm going to store it in a variable t. So turtle set speed to 0 is going to let me make the turtle move really fast. So once I set the speed to 0, then I'm going to hide the turtle because I don't want the turtle to be seen. I just want to see the circles that I'm drawing. Then I'm going to set the colors to a list of colors. Now I plan on having about 6 colors, but I didn't want to type them all out because I wanted to decide on the colors later. So number of circles that I'm going to draw is going to be 360 divided by whatever the gap is. So the gap that the user is putting in, we're going to consider that an angle. So for instance, if they have a size 1 gap, then there's only going to be 1 degree between each of these circles that are being drawn. Remember, these circles are being drawn in a circle. Okay, let's talk about how this loop works.
Let's assume num circles is 36. That's what you'd get with a gap of 10 degrees. The loop is going to generate the numbers from 0 up to, but not including, num circles, so 0 to 35. That's the pattern or sequence that this loop creates as it runs. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. up to 35. So because we're only going to have 6 colors for the circles that we draw, we need a different pattern or sequence to happen while the loop is running to get those colors out of the color lists. So that's what this mod function is doing. It takes the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. and turns them into 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. It uses this second pattern to get the colors from the lists each time through the loop and set the turtle to the right color. The loop also draws the circle and then turns the turtle a certain number of degrees so that it's ready to draw the next circle the next time around.
And this is our pseudocode. Okay, now what I've done is I've taken my pseudocode and I have put it into a Python program called main.py. I turned this top comment into a multi-line comment that is a description of what the program is supposed to do. And then I put a pound sign in front of all the lines of pseudocode because I'm going to use them as comments for my program. Okay, I'm actually going to write the program in this file, but these comments won't interfere with the program because they've been commented out. Here I'm going to display, please enter gap size, and then I'm going to take that as the size of the gap. So we usually do that in one line of code in Python. Okay, I'm going to write the rest of this program now. What I've done is I've added code after all the different sections of comments. So the comments actually guided me in the code that I wrote. So let's run the program and see what it does. Okay, so now if I run it and I put a gap of 10, oh, there we go. So, and this is what it produces for a gap of 10. I could also have made a gap of 1. That's how you get from pseudocode, well, from an idea for a program that's simple enough that you can quickly pseudocode it all the way to a running program.